Welcome back to Advent of Code 2024, Day 8. Welcome in, Bad Cop. Welcome, DJ. Alright, yesterday was quite an easy problem, so what do we think about today? Let's find out. Hello, Smab UK. Have you done this one already? Alright, it's on a grid. That's usually a good sign, I usually find. Resonant collinearity. Today was easy but confusing. Okay. You find yourselves on the roof of a top-secret Easter Bunny installation. Oh yeah, I remember the Easter Bunny year. A Sembunny. Ah, I remember that. While the historians do their thing, take a look at the familiar huge antenna. Hello, Flynn. Much to your surprise, it seems to have been reconfigured to emit a signal that makes people 0.1% more likely to buy Easter Bunny brand imitation mediocre chocolate as a Christmas gift. Unthinkable. Scanning across the city, you find that there are actually many such antennas. Is it antennas or antenna? Probably both are correct. Each antenna is tuned to a specific frequency indicated by a single lowercase letter, uppercase letter, or digit. You create a map of these antennas, for example. Alright. Signal only applies its nefarious effect as specific antinodes based on the resonant frequencies of the antennas. In particular, an antinode occurs at any point that is perfectly in line with two antennas of the same frequency, but only when one of the antennas is twice as far away as the other. So they're on a line. Do they mean vertical and horizontal? Hang on. No. It means vector line. So it doesn't matter whether it could be at any angle, I guess. Yeah. Well, they'll give examples. But only when one of the antennas is twice as far away as the other. So they could be on the same side, or it could be sandwiched between them, I guess. This means that for any pair of antennas with the same frequency, there are two antinodes, one on either side of them. But why is it not allowed to be between them? It would still be in line, and you would still satisfy one is twice as far away as the other. So shouldn't there be up to 3 antinodes? I don't totally grok this one yet. I'm hoping you'll clarify for me, and then I'm out. So it seems they want it to only be antinodes outside, on the outsides. But I don't agree that the description excludes antinodes on the inside. Okay, fine. Adding a third antenna with the same frequency. Okay, so for these two antennas with frequency A, they create two antinodes marked with hash. So yeah, in this example, there's no node which would fit between the two. But if it was there spaced out a bit more, I would think I mean, look, if that was A, then surely these would both be antinodes, because the same logic works in reverse. That would be an antinode, and that would be an antinode. And there'd be an antinode down here somewhere, and there'd be an antinode up here somewhere. There'd actually be 4 antinodes. Okay. Adding a third antenna with the same frequency creates several more antinodes. It would ideally add 4 antinodes, but 2 are off to the right side of the map. Instead it adds only 2. Oh! So they are... So you are allowed to add 4 antinodes. So what do they mean by this sentence here? Do they mean at least 2 antinodes? They're saying there's always 2 guaranteed? Okay. Antennas with different frequencies don't create antinodes. Those are 2 different frequencies. However, antinodes can occur at locations that contain antennas. In this diagram, the lone antenna with frequency capital A creates no antinodes, but has a lowercase a frequency antinode at its location. Okay. Alright. Because the topmost A frequency antenna overlaps with a 0 frequency antinode, there are 14 total unique. 2 are out of bounds, so don't play. Yeah, so it's assuming there was no bounds, it would actually have 4. So really, there can be at most 4 antinodes, but I think this is saying there's always 2. Yeah, there's always 2, but I mean, assuming they fit. Okay, assuming it's an infinite grid, there's always 2, because you just take the vector from one node to the other, and then repeat that vector, and that'll get you to one of the antinodes, and do the same the other way. But the ones on the insides may or may not exist, depending on like, I don't know, coprimality or something. We'll figure that out later. So 4 antinodes. Okay, so adding a third. So they're adding a third here. Oh no, they mean 2 on the outsides. So we're not allowing antinodes on the insides at all. But they don't explicitly say it. I am still a bit confused about that, but it seems to imply we're only allowing them outside and not inside. The exact wording was that sentence there. I would think that would allow nodes inside. Fine. We'll just assume they meant nodes outside only. Because the topmost A frequency antenna overlaps with a 0 frequency antinode, there are 14 total unique locations that contain an antinode within the bounds of the map. Calculate the impact of the signal. How many unique locations within the bounds of the map contain an antinode? So didn't I basically already say the algorithm? You compute the vector for given pair of frequencies of the same frequency. Given pair of antenna of the same frequency, you take the vector from one to the other, double it, and that gets you to 1 antinode. Do it the other way, and that gets you 1 antinode. Check whether they are in the grid, and then iterate over all pairs of 1 frequency. We don't want to iterate over all pairs of antenna, because we can cut that down just by restricting to all pairs within one frequency group. Okay, I think that's basically the algorithm. And the location you have to... You don't really have to do any checks. They're allowed to be in the same place as other antennas. They're probably allowed to be in the same place as other antinodes as well. It wouldn't matter because we're looking for unique locations. Yeah, so they're allowed to be anywhere. Okay. So I think we want to create basically a hash table that maps a symbol to a list of all the locations where that antenna can be found. To start with. Yeah. Alright, so this was similar to, well, we've got grid stuff, so let's look back at 6. We can probably copy some of this code here. We could reuse our pos code as well. Copy all of that. Alright, so grid is that with row equals line.strip. We don't need to do any of this yet. We even want the isInBounds method. Should we make that a pos method? As long as n and m are global variables, I guess. We don't need rotation. Okay, so we do want add, because we're going to add 2 vectors together. Equality and hash, just leave those in. Yeah. We could even have subtract, because we take a vector, we add it, and subtract it to get the other way, I suppose. So that's how we handle a vector. Okay. Just run that. Alright, so we'll just populate dict of sim frequency like that. We're just gonna make a map of a given frequency, get the positions where antenna are located. So just say from, let's use a default dict. Okay. Antenna. I gotta look this up now. Is antennas the right plural? It's antennae. That's what I thought it was. Formulae. Oh, okay. Antennas is correct. But I'm pretty sure I've always been taught antennae. Formulae, stuff like that. Maybe it's a British thing. Alright. Well, I'll just use what I'm used to. Antennae. Equals default dict list for I in range n for j in range m if grid ij is not equal to dot. We're gonna do antennae on that symbol. Dot append pause ij. Just pop a pause in there. Print antennae. So C W, okay, that looks good. So just brute force keeps working for me. I wouldn't say it's true brute force, like we're gonna have some restrictions, like restrict to within within frequency groups. That's at least one optimization which would have a significant effect. So true brute force, I suppose, would be just like, it is debatable what true brute force even means sometimes, but maybe it would be like true brute force will probably be iterating over all possible points where anti-node could be, and then seeing if and then also iterating over every pair of antennae and seeing if those two antennae are A, the same frequency, and B, induce an antinode there, which would be a huge amount of complexity, I suppose. I would say that would be the true brute force, like you're iterating over every spot, every pair of antenna, or every spot. The second and third spots, you're checking if they're antenna or not. So it's literally iterating over the grid 3 times. So that's kind of like sextic, hextic. What's the word in Latin? You basically ordered n to the 6, where n is the width of this graph. Okay, so I wouldn't call this brute force, no. It's just a smart range. So we're gonna go... What is the end result we want? We want the set of unique locations, okay. So let's say anti-nodes equals an empty set. So we want to so we don't care what the symbol is, we just care that we now know where symbol groups are. So for antenna group in so this will just be the lists. Brute force, in the sense you described, would be so much harder to write. Yeah, sometimes true brute force is actually harder to write. Yeah, that's true. It's the only property that qualifies as brute force is complete naivety of how you're doing the ranges and stuff. Basically, just trying all possible values for every variable within the bounds. So yeah, it wouldn't make sense to code it that way, but it is what I would personally call the brute force approach. But brute force is normally something that's, I don't know, I normally think of it in terms of decision problems where you're searching through a space and trying to find a certificate which shows a yes answer on a like a question about a subset of. Okay, I'm throwing too many terms in there. I don't normally use the brute force, the term brute force in these kinds of contexts, so I don't know how people normally use it. I don't think the term brute force applies to this problem. I would agree, for some of these problems I don't like that people are overusing the word brute force, like the one where you're searching you're making the guard run around. I don't think of that as brute force, I think of that as literally running the simulation. For simulation problems, there may exist quick ways of cutting out steps of the simulation, but regardless, you're not really searching through a space. You're simulating a set of steps. Like, yeah, I don't like using the term brute force there. Is AC even working? Hang on. They always have so many buttons on these things. Yeah, it is. Okay. Alright, so for antenna group in antenna.values, I guess we just want to do for, let's say, A1, so for I, A1 in, in enumerate antenna group, for J, A2, for J, A2 in, wait, how would that, just say this, for J in range I plus 1 length of antenna group A2 equals, I'm sure there's a way of using it, I forget like the parameters that you supply to enumerate. It's one that I don't want to risk getting the index wrong. A2 equals antenna group J. So that ranges over all unique pairs. We want to compute the vector from A1 to A2. Vec equals A2 minus A1. We've got subtraction. Anti-1, let's say anti-node 1 equals so it's going to be vec plus A2. We apply the vec, so adding the vec to A1 gets to A2. Adding it again gets one more unit of vec away. So that should be twice the distance from A1 as it is from A2. And T2 equals A1 minus vec. Okay. And then hello Eldin. How goes the AOC? Part 1 seems alright so far. I I'm somewhat confident that this will work. I think I'm close to finishing. And then we just want to say if anti1.is in bounds. Is that how we called it? Is underscore in bounds. Anti-nodes dot add anti1. Let's do the same for anti2. Print length of anti-nodes. Anti-gravity. Oh my god, was that XKCD joke from like decades ago? Import anti-gravity. Look this up in the doc. Have you ever tried it in Python? Well, let's try running it now. It opens up the XKCD comic in the browser. Hang on, let me do that again. Forgot all about that, man. This comic, this one comic here was partly what got me into Python. I think this is the first time I even heard about it when I saw it mentioned here. But it wasn't what got me started coding. I then saw more references in other places and then at some point started it. But yeah, this is probably the first time I ever heard of Python when I saw this comic. When was this? Doesn't say the... Doesn't say the date. We have all of his books. I gotta check them out. He's done a lot of stuff in the last decade or stuff that I just didn't know about. I mean, I don't read the comics anymore. I stopped years ago, but so every now and then, like, some of them make their way to other sites and I see them. Cool. I go away for 2 minutes and now we're browsing XKCD. Well, my code popped that up in the browser. This came up in the autocomplete anti-gravity, and I forgot all about this. But yeah, this is something that's actually in Python and has been since that comic was launched. Import anti-gravity. It basically just opens up that comic. 371. Unique. Okay, let's try it. 371 sounds about right. Okay, correct. Yeah, it was added like a week after that comic came out. Do you know when that was? Probably there's an archive somewhere which says the dates of comics. All right, part 2. Watching over your shoulder as you work. One of the historians asks if you took the effects of resonant harmonics into your calculations. Whoops! After updating your model, it turns out that an antinode occurs at any grid position exactly in line with at least 2 antennas of the same frequency regardless of distance. Alright, now we're getting into some light number theory, I suppose. This means that some of the new antinodes will occur at the position of each antenna, unless that antenna is the only one of its frequency. So these 3 T frequency antennas now create many antinodes. But it still has to be outside, so we're not allowed on the inside. I feel like that was missing from the description. They should have said that. To me, if in between is just as valid as outside, but it seems from these diagrams they want it to only be... Oh, hang on, what about this one? No, this one's still on the outside. Okay. So, So I guess once we find the vector, well, we can take out the common factors to find its unit, its smallest unit. The antenna don't create antennas between them. Oh, if that was in there, I must have missed it. It isn't, but it's a consequence of the rules I give. Is it? I've not seen anything in the rules which would imply that. At least I don't see why that would be the case. The only hard rule I've seen is this. In line with 2 antennas, and twice as far as away from one as the other. To me, inside would be completely in line with that rule there. I don't see any other rule that would imply they can't be between. Michael PC Gamer, thanks for the raid. Were you by chance doing any Advent of Code? I've just started on part 2 of this. It doesn't look hard or anything, but we were just discussing both parts of today. So I was just discussing that I don't particularly like that they aren't allowing antinodes between the two antenna. Or at least there's nothing in the rules I see that would exclude that. But apparently they don't want us to count those. But there's nothing, no actual statement saying we can't have them, so that kind of bothers me. But fine. So okay, so I've just read part 2. So, Michael, what were you coding in? Okay, let's go back to Python. Nice. I'm doing Python as well. Alright, part 2. Alright, I suppose we can just... Well, at least in my input, none of the antennas that existed had spacing which allowed for a node between them, which followed the rules. Okay. Yeah, I don't know. But yeah, I'll code it according to this assumption that was never stated, but, oops. part 2. So we've got antinodes again, just do the same thing again. So as soon as we get here, we get the vector. Now what? I guess we want to... we want to take out... We want to see what the smallest unit is. We want to see... Factorize this vector and see what the smallest vector is that this is a multiple of. Would that necessarily cover all integer spaces? It should, yeah. Every time this vector crosses a point, anytime any multiple of this vector crosses an integer set of points, that point would necessarily be A2 plus some multiple of that smallest unit. Yeah, I believe that's true. So if we were to just add a method for our pos class, say define get, what is the term for this? Get highest common fact HCF vec, highest common factor vec. There's probably a proper mathematical term for this. So we're trying to so we want the highest common factor of I and j. Divide that out. So HCF, is that actually in equals I don't think we call it GCD normally, don't we? G, greatest common divisor, and that is a method somewhere in Python. Equals is it fractions.gcd? Yeah. So we will return the pos, which is self.i, divide out the GCD, self.j, divide out the GCD. So just do this in this one loop. Just say antinodes P1, antinodes P2. Alright, so let's get rid of all this. Alright, so we get the vec, we do that, we can say P1, alright, so just say that's part 1 stuff. And now look onto part 2. I got lucky in how I coded my part 1 solution in Rust, only required changing 2 keywords to work for part 2. Yeah, it seems like the change can be very small, really, depending on how you've coded this. I mean, with vec, I could pretty much I'm not going to, but I could pretty much do the next bit with a one-liner. It would just have to include that baked into the logic. So we'll say GCD vec equals vec dot vec dot, what did I call it? Get GCD vec. So now we just take A2 and we just keep adding GCD vecs until we go out of bounds. And then A1 and we keep subtracting GCD vecs. Is this correct? Feels right. There shouldn't be any other integer coordinates which would lie on vec. Alright, yeah, let's do this. So let's start with and we need to include the antenna themselves. Okay, so let's say temp equals A2. So we're sitting on A2. It would be helpful if I made a diagram here. While A2 dot is in bounds, no, while temp is in bounds, add it to antinodes P2 because that is valid. And then we want to say temp plus equal GCD vec. Just do that a bajillion times, and then probably won't be that many. And then just do the whole thing again. But from A1 backwards, so this should get us A1 and A2 as well, because we need both of those. Let me look at the description again, make sure I've understood this correctly. Any grid position exactly in line with at least 2 antennas of the same frequency, regardless of distance. But not inside. The bit they're not saying. Okay. Some of the new antinodes will occur at the position of the antenna. Yeah, okay. Temp dot is in bounds, antinodes P2 dot add temp minus equal GCD vec. Alright. I'm confident. Module fractions has no attribute GCD. I think that's an old thing. This is outdated. I think we need to use... I've just got to Google this. Math.gcd? Did it used to be in fractions? I don't know. If it did, it was probably a very long time ago. 1229, so it's about 3 times the size. Seems hard to tell, really. Seems about right, considering that these vectors are usually will only fit like 2 or 3 more in many cases. Alright, 1229. And for singletons, we're not doing anything. That's safe because they don't count as pairs. Correct. So, out of interest, I could just test whether there were any inner vectors. So we could say, just add one more condition here. So if I were to code without looking at their examples, if I were to code it based purely on their description, this is what I would have done. I would have said temp equals A1 while temp dot is in bounds to temp plus equal GCD vec. So that should also include all inners as well, anything in between them. Let's try that. It's still 1229. Okay, so they've chosen the input so that there's nothing between them. So it wouldn't harm us if we did code it that way. It's a bit weird, but okay, fine. As long as the input satisfies that condition, I guess I have no valid complaint, really. Cool. Yeah, nice problem. It requires basic understanding of vectors, really. I mean, you could come up with all these vector stuff from first principles, but it helps to know basic vector algebra, especially if you're going to put a class together like this. And then when it comes to the greatest common divisor, it's sort of common sense, but yeah, that's the thing which comes up in mathematics, definitely. And if someone didn't know, well, okay, some languages don't have GCD, so then you'd have to do what? Euclidean algorithm, one of the oldest algorithms in academia, to to calculate the GCD. Don't think it really needs an understanding of vectors. Well, I would argue the fact that they're using the phrase in line with antenna, that's almost implicitly talking about vectors. I don't know. You don't have to use a vector class. I agree with that, definitely. But I would think you need to understand the most basic concept of a vector to actually understand the phrase in line with antenna, and to also understand that these integer coordinates will appear at multiples of this. I mean, I suppose you could do a different way. You could draw a line and just use rounding to see how many coordinates it crosses, how many integer coordinates it crosses. I'm not sure how. It's a bit messy, but that's you could do it without computing multiples of a smallest vector. Or alternatively, you could range over the or, I mean, you could just, for a given pair of antenna, I suppose you could actually just range over the entire grid for each point, see if it's in line with them. That's still sort of vector algebra, but yeah. Initially, I thought every index meant if the point are 0, 0, and 5, 5, then 6, 6, 7, 7, 8, 8, and so on were anti. But they are, aren't they? Oh, are you talking about for part 1? Oh, but no, it has to be 10, 10. Oh, yeah, for part 1, yeah. So part 1, it has to be only the nodes such that... Oh, part 2. But 6, 6, 7, 7, 8, 8 should be in there, shouldn't they? For part 2. Oh, no, sorry. Okay, sorry, I read your description again. 0, 0, 5... Oh, yeah, no, yeah, 10, 10. So it has to be... No. Wait, I'm getting confused. So we take the vector, we simplify it. Yeah, it should be 667788. Because you got part 2, right? Don't want to spoil. Yeah, I've done it just now. Yeah, so the vector would be 5, 5. And you take out the GCD, it should be 1, 1. So 6, 6, 7, 7, 8, 8, 9, 9 should all be antinodes. They should be. Have to be multiples of the distance. They would be in line, but not antinodes. But the way I've coded it, they would be. Wouldn't they? Also, it doesn't say anything about having to be multiples of distance. It just says they just have to be in line. Any grid position exactly in line, regardless of distance. So it actually says regardless of distance, not multiples of distance. I was doing multiples, I think. And it worked? I would say, for that example, 6, 6, 7, 7, 8, 8 should definitely count. And the way I've written my code, it would count them. Maybe the input has been super generous. But, I mean, they have used the phrase regardless of distance, so that unequivocally means distance is irrelevant. Got the slope, then iteratively added rise and run to I and j. I guess because there were no antinodes between them, that already proves that the vector actually doesn't break down, so maybe my GCD actually was superfluous, but I would argue the way I wrote it with the GCD still is correct according to their description. But nothing in the description says it has to be multiples of the distance, so... So yeah, I think it was just a very generous input. And there was... Actually, the T example implies it. In my input, that method would never produce a point between the original pair. Yeah, it seems the input they gave didn't have a point between the pair. But the way I'm reading this, regardless of distance, I would say if there was an input which had 0055, then 667788 definitely should be included. It's a strange one. Yeah, I'm not sure I like this description. I mean, there's nothing wrong in this description. So I have no valid complaint here. The way I've coded it matches the way other people have coded it if they've just gone with multiples of distance. It just means I had to do more work using the GCD to write. If I were going for the leaderboard, maybe I would be bothered by that, but then... whatever. I did have code to try dividing the differences by 3 to see if there were internal points originally, but there weren't any, so I took it out. Yeah. I mean, the only correct way to find any points between them, I think, is what I did with the GCD. That's the number theoretical proof whether or not there are points between. Any point between would necessarily mean that that big vector is a multiple of a smaller vector, and in that case that means there is a common factor between the two, between the x's and the y's. That's very odd. Yeah, so yeah, nothing was wrong in the description, except I would argue this sentence here. Because this sentence is saying the previous sentence implies this condition. But I don't agree that 2 antinodes is a logical result of that last sentence. I would say 0 to 4 antinodes is a logical result of that last sentence. I mean, these 2 antinodes might even be out of the map as well, so there will always be 2 outside nodes. If they are within the map, yes, I agree. But the way this is worded, it didn't say at least 2. It seems to say there are exactly 2, whether they're inbounds or not. That's the way I'm reading it. So that's the only sentence I don't actually agree with. I would say it would be technically correct if it said there are at least 2. But then apparently there are no inputs with more than 2, so whatever. I guess that implies no inside antinodes, but then it shouldn't have. Then they shouldn't have used the phrase "this means that." That's the only bit I have an issue with. Because when they write "this means that," they're saying that this logically follows from this. But what they actually really mean is this logically follows from the way we've devised the inputs. But the "this" here really is referring to that last sentence. So if they had cut "this means" out. If they cut these 3 words out, and then just say, for any pair of antennas with the same frequency, there are 2 antinodes, one on either side of them, then I have no complaint. That's actually establishing a rule going forward, that there aren't going to be any antenna inside. But when it says this means that, that's what tripped me up, because I don't see that following from the last sentence. My solution in the link above will look too simple then. I mean, it worked. Also, when you read that sentence, I mean, you'd end up doing what I did for part 1 and ignoring anything in between. So, that's fine. Let me just... Alright, I'll pull up your code. I think the only... If anyone was going for the top leaderboard spots and they spent time doing GCDs, they might have a complaint, but doesn't bother me. I'm not going for the leaderboard. Resonant collinearity. Oh nice, you used antennae as well. Yeah, okay. Yep, that's cool. Distinct. And then you just go... until it's out of bounds, right? Considering that I've only cracked the top 10k a few times, I don't have much shot at a leaderboard spot. It's becoming harder and harder now that AI coders are taking the spots, and I believe I believe they're not, the moderators of the site are not actively removing people from the leaderboard. They're just leaving people on the leaderboard, even if it's been proven that they are AI. I guess they decided it'd be too much work, and they don't want to establish a precedence, because if they remove one person, then that basically means they're committing to seeking out and finding AI solvers and having to do it. So I guess they just don't want to establish a precedence, so they're just leaving them on the board. So unfortunately, every day there's going to be AI coders at the top spots. 14 seconds. 14 seconds, I think, for even for the easiest problem, seems a bit too fishy. Do you think people are actually using AI? It's been proven. Some of them have even admitted it, because they said they didn't realize it was against the rules. And to be fair, the rule is actually buried at the bottom of the FAQ. So it's not even on the place where you submit and stuff. So it's actually so yeah, some people were caught because they left markers in their Git code. Some people were completely open about it, and as soon as it was pointing out to them, they were like, oh, I'm sorry, I won't do it anymore, and then they didn't submit for the future days. So fair enough. But they actually didn't know it was against the rules, so I feel like they could have actually put something somewhere other than... I mean, where even is the FAQ? About? Here it is. This is the only... No. Here is the only bit which explicitly tells people not to use LLMs. But that's not... No one's actually gonna... Most people are not gonna read all this, let's be realistic. I think, obviously we can't stop them altogether, but if they just put something at the forefront a bit more, like at the point where you're submitting or something, that probably would have cut out a lot of people, because a lot of them actually were honest and said, no, they just didn't know it was against the rules. It's very much common sense. It's common sense for those of us who have been in this a long time, but now a lot of people have just started coding in the last couple of years, and they've actually started coding with ChatGPT, and they've actually integrated their learning process with ChatGPT and stuff. So I don't think for them it's actually common sense, it's actually obvious, and I think it does actually need to be stated. Like, I think a lot of people have started learning coding in a different way that we have, and they assume it's normal and allowed for these types of competitions. So I think it does need to be stated somewhere. I don't think it can just be attributed to common sense, really. Especially for people who have literally just started coding in the last year or so and have never participated in these We've spent 99.999% of our history as humans not having access to digital things. Yeah. Still taking exams on paper. Yeah, that's... Like, the only... Well, I was about to say... Submitting your code is how some of the coding sites did it back in the day, but that wouldn't even change anything, because the AI gives you code, which you could then paste into the file. I mean, that's how HackerRank did it. Yeah, no, you can't. The simple answer is you actually can't detect AI. Anyone trying to sell you a tool and claiming it's an AI detection tool, they're lying. There are no AI detection tools that work 100%. In fact, their accuracies are kind of rubbish when actually analyzed. So yeah, you can't actually do anything to prevent it, but you can take measures to at least inform people. I would think maybe a couple more measures could be taken. but that's the extent. That is as far as it goes. Like, you can't do anything more than that. This type of competition is for humans, not AI. Yeah, I agree. I think it should just be made clearer somewhere at the point at which you're submitting that this is what Eric was going with. I think most people with any coding experience agree that AI is cheating on this sort of thing. Yeah. Especially as you can't analyze the answer. I mean, I have to admit, at the 2 or 3 years ago, when people first started using LLMs, and I had never touched LLMs, I had never touched ChatGPT, I didn't see anything wrong with using them, but then I didn't know how crazy powerful they are at the time. So then the next advent of code, I committed to using AI after I solved it myself to see how it would have compared against myself, and it beat me most of the time. And then I realized it is actually completely taking away the point of this sport. Some people will cheat and some people are clueless enough to not realize it's cheating unless they're told. Yeah, some people can be ignorant, but I think they're also innocent in not knowing at the same time as being ignorant. Oh, I didn't know I can't use... I don't really agree. Like, if that were true, if they were committed to cheating, then those people would have carried on submitting for the remaining days. But the fact that they stopped the moment someone told them, to me that says they were innocent. They just genuinely didn't know, and were just genuinely ignorant of that rule. Like, if they wanted to cheat, they would have just ignored people telling them that it's against the rules, and they would have just carried on submitting. Well, anyway, we can't really get anything from the global leaderboard anymore. Either way, whether or not measures are taken, because there will always be top spots. But we do have private leaderboards. I've got mine, which is here. Anyone's free to join. In fact, I can copy the thing here. I've met people who equate programming with writing LLM prompts, think of themselves as programmers, but couldn't program anything belong. Hey, hello world. Yeah, that's what I'm saying. So, it's obvious and common sense to coders, people who can code, that is against the rules. But some people literally have only used AI to code and to develop scripts for them. In which case, to those people, that's all they know. So it's not obvious to them. And they don't even realize that there is a thing called coding, which we do, or they may just not really realize that the point of this was to code these yourself. I don't know. So that is the leaderboard. That's my leaderboard. But then there's another one I do recommend, which is Captain Coders. Captain Coder is a computer science educator who does a daily stream for these. And that's Captain Coder's leaderboard as well. And he's got an active Discord. I don't have a Discord myself. I'm not interested in having one. But so if you want a place with people who I believe are not using AI and not cheating, if you want to discuss with people about problems, Captain Coder's Discord is a good place to go. You can find Captain Coder on Twitch, just search for Captain Coder. And he will be streaming in like 2 or 3 hours time as well, I believe. If he wants to. Some days he doesn't have time to, but okay. So that's day 8. I will try to, so I have to fly somewhere tomorrow, and I don't know if my hotel will have good enough Wi-Fi, but at the very least, I might just record offline and upload to YouTube if I am not able to stream. but I will try to stream around the same time tomorrow. Let's see if anyone else is doing. Advent of code. Kuviman is live again. I raided him before. I guess this guy's in German, so we'll go with Kuviman. Last year was the first year I did it. I only got 23 stars. 23 is a good number of stars. Was that a lot of part ones, or did you have a fair few where you got both parts? The only year I have left to do is 2021. I'm saving that for the middle of 2025 so that I can space things out a bit. So yeah, I'll do a stream where I'm doing that, but then I'll be all caught up, I guess. And I'll join the 500 stars club. All right. Thanks again for the raid, Michael PC Gamer, and thanks everyone for watching. I will be back every day if I can manage around the same time in Python. See you next time. Bye bye.